In this lesson, we'll see how to use Nginx's built-in rate limiting module to create what can be thought of as traffic lights for incoming connections. Rate limiting a server implies, rather than simply limiting, managing incoming connections to the server for a specific reason. Common reasons to rate limit a server can be to add an extra layer of security against potential brute force attacks, preventing traffic spikes for a more reliable server, or even to restrict users to a service based on their tier, something like a download service, for example. Now, given the tools we have at our disposal, which right now is the browser and Apache Bench, testing our server's rate limiting is going to be a bit difficult. What I'll do then, to better demonstrate the outcome of connections to the server, is install a new tool called Siege. Siege is a lot like Apache Bench, but focused more on load testing a server, rather than benchmarking it. A minor difference, but one that will suit the needs of this lesson better. To install Siege then, again using apt, I'll say apt-get install Siege. To install this on CentOS, you'll most likely have to build it from source, which is simple enough, and instructions can be found in the documentation, which is linked in the lesson resources. That's all done, so to check the tool is working, let's run a test to the demo site for that image, thumb.png. I'll say Siege with a V flag for verbose logging, R2 meaning run 2 tests of C5 being 5 concurrent connections. So 5 concurrent connections, then another 5, 10 in total, to thumb.png. Enter. And that finishes almost immediately, resulting in 10 hits, 5 times 2, and 10 of those being successful, so clearly no limiting here. This output now demonstrating why this tool is going to work better for these tests, as any failed or rejected connections will also appear in red, just a bit more visual. Okay, so with that done, let's implement some basic rate limiting. Over to the configuration file, where, like the fastCGI cache and the SSL session cache, we'll define a new memory zone in which to track connection limits. Limit request zone. And the first argument to set here is again a key with which to identify how rate limiting is applied. For example, if we set this to the server_name variable, rate limiting will apply to requests based on the server name. So essentially all requests to this IP. If however we made this key binary remote address, which is the connecting IP address, rate limiting will be applied per user, as each connecting client will have a unique IP address. This per IP limit being perfect for something like rate limiting a login form, and thus preventing or rather severely slowing down a brute force attack. Or in our case, I'll use request_URI, meaning limit connections per request URI, regardless of the client IP or anything else. If a certain URI, for example thumb.png, receives more connection requests than the zone allows, apply rate limiting. Next, specify the zone name. I'll make this my zone, colon, and the size of this zone in memory, 10 meg, which will be plenty. With the last parameter being the all-important rate. This takes a unique format of the number of requests, say 60R for 60 requests, per, with a slash, and an Nginx time format, like M for minutes. So this zone now saying limit requests to the same request URI to not exceed 60 requests per minute. Very importantly, note that this does not mean the server can accept 60 requests at once and then no more for the remainder of that minute, but rather it sets a frequency of requests for this time frame. In other words, this 60 requests per minute is the exact same thing as saying 1 request per second, or 3,600 requests per hour, and so on. The point being that Nginx will apply rate limits evenly, thus preventing traffic spikes. Okay, then with our zone created, we can add it to either the server context, so apply to all requests on the server or inside a location context, like this default location we have here, meaning we can test it on that thumb.png image. Say limit_request zone equals my zone, the name of that zone we defined. Save this, reload the configuration, and run that same test again. 5 concurrent requests for thumb.png twice. Enter, and this time round we get only the very first request succeeding, with the remaining 9 resulting in 503 errors, which is service unavailable. So what happened here? The way rate limiting is applied is the server received 5 connections at once, being the first batch of siege requests. It responded to the first one of those 5, being that we're allowing 1 request per second, and immediately rejected the remaining 4. This obviously happened very quickly, well within a second, meaning that when the second batch of requests were sent to the server, that 1 second limit had not yet passed, and all 5 requests of the next batch also got rejected. This being the default rate limiting behavior. If we change this to perform 2 tests for a single connection, same. As now the 1 second has elapsed since the last test, but again the second request gets denied as soon as that second limit starts again. Let's say, however, I manually perform a curl request for thumb.png, again only checking the headers for the status code. The second from the last test has elapsed, so enter, it works. Wait more than 1 second and run this again, another 200 success. More than a second, and so on. So as long as these requests are sent more than 1 second apart, no limiting is applied. 1 second being extremely aggressive, of course, but for the sake of demonstrating. Okay, so that's the default rate limiting behavior, but the zone directive does allow us to change this behavior somewhat. The first we'll look at is setting a burst limit, by specifying on the zone directive burst equals and a number, for example 5. Thus applying a burst allowance, which we'll discuss in a second, to all implementations of this zone. Alternatively then, to better specify where we enable bursts, we can also specify this on the limit request implementation, like so. Just a more granular way of configuring the rate limiting behavior, especially if you have multiple implementations of the same zone. So what does this burst allowance do? Basically, setting a burst changes that default behavior of immediately rejecting all requests exceeding the limit to allow this number of requests to also be fulfilled, meaning our server will now accept 1 plus 5 connections within the second. It does not, however, mean that these 5 will be responded to immediately. Instead, they will still have to adhere to the specified limit, only that they will have to wait and won't be rejected with that 503 error we saw. This then provides a bit of a buffer, and rather than creating hard limits, allows us to implement what would be considered more traffic shaping, so slowing down connections. Save this and reload the configuration. Run that first test again, 2 lots of 5 concurrent connections, meaning we're within the 6 total allowed. And this time the first is responded to immediately as before, and the remaining 4 gets fulfilled 1 every second, so perfectly within the rate limit. Then, once the second batch of 5 connections is sent, we're still within the rate limit, and again the same shaping occurs. So all 10 requests is successful, but taking 9.3 seconds, nearly 1 second per request. Only the first immediate request making up for those few milliseconds. So a much more eloquent way of limiting, say, front-end traffic, for example. Change this test to exceed the burst, however, say 15 concurrent connections, doing only 1 lot this time, and immediately the exceeded number of requests is rejected, whilst the remainder gets throttled to 1 per second. Leaving us with the total 6 requests succeeding, 1 plus burst, and the remaining 9 immediately receiving 503 errors, as they were outside the rate limit and the allowed burst. The final modification we can apply to our limit zone is the no delay parameter, this only being applicable to a zone that already defines a burst value as well. Essentially, no delay says serve the allowed burst requests as quickly as possible, so not adhering to the rate limit for the burst requests, but, very importantly, still maintain the applicable time limit for any new requests. Meaning, if we perform 6 concurrent requests, even though they will all be served as quickly as possible, the rate limit will still only reset at 1 request each second. This might sound a bit confusing, so let me demonstrate again. Save and reload the configuration. I'll run a single test for the full 6 requests only, and as soon as that is done, which should be very quick due to that no delay parameter, I'll run the same one again. Enter, again, and done. So what we can see here is how long it took me to run the second test then. The first 6 requests were all responded to successfully, as per our rate of 1 plus 5, the burst, which all in all took nearly a full second. And then it took me little over another second to run the second test, as we only managed to have 2 of those requests responded to, meaning the total limit of 1 request per second, making 6 seconds, was still active. And the 2 seconds it took until the second test ran freed up 2 requests in that limit, which is what the no delay parameter allows us to do. That wraps up rate limiting, and given these 3 variations of default, burst, and no delay, the limiting strategies are endless. If this got a bit confusing towards the end, be sure to watch this lesson again, and also take a look at the excellent article linked in the resources.